Well, good evening from Emerald Hill Skies on the outskirts of Louisville, Kentucky. My name is Doug Lucas, and I'd like to welcome you tonight. If you're watching us live or if you're viewing this later on the recording, we're glad you're here. It's a cold night here in Louisville, 27.7 degrees out at the scope, a little sensor on top of the scope, so nice and frigid. Tonight's a special night. It's our 100th observing night. We keep records as we go. We've transferred through actually 2 or 3 different record-keeping systems, but here we are in our record-keeping system called Deep Sky Planner. Deep Sky Planner, and we're on our 100th observing night, and this is our 150th live stream, 150th recording, I guess I should say. Some of the recordings were actually regular videos that we uploaded, so I should say recording. But on this night, we are glad you're here to kind of celebrate. I thought in between things tonight, I'd maybe share a couple of memories. Some of you that have been here with us for, I don't know, throughout the 2 years that we've been observing, maybe you might remember some of those scenes that are going to be kind of poignant for me. But let's also do some observing. So let's go ahead and get started. We actually got the scope pointed at an object called C41. We're in the Caldwell list tonight. So again, this is another Stephen James O'Meara book, but it's actually a book written about a different list that he didn't make up. If you've been sticking with us lately, you know that we've been doing hidden treasures, and we've also been doing secret deep list, and both of those were lists that he kind of contrived. But the Caldwell list actually comes from a man who in somewhere around 1995 or 1996 wrote an article for Sky and Telescope, and he had noticed that in the common list called the Messier list, it's kind of made famous number of objects. He noticed that there were several objects that were not included that were actually quite beautiful. So Sir Patrick Moore actually decided that he would, come up with a list, and he sent it in Sky and Telescope, and he said later he was surprised at how quickly it became, I guess, embraced by the masses. And sure enough, people all around the world were starting to go to this list as kind of a 201 version. They would go to the Messier list like the 101 version, some of the biggest and brightest objects, not all of them, but quite a few. And then they'd go to the Caldwell list when they kind of graduated from the Messier list. We've often joked, after the Caldwell list, maybe you go to the Herschel 400. And after the Herschel 400, somewhere in there, you might go to Hidden Treasures. And after that, you might go to the Secret Deep, which we've been working on lately. It's been quite a while since we've worked on the Caldwell list. The way the sky is, you have to wait until the sky kind of sort of turns a new set of objects for you throughout, the seasons as they change. So let's get going over here and check out the Caldwell 41. It's also known as Malott 25. Malott 25. And let's do a color balance and move our black level kind of here along the top of these crests, and move our mids up a little bit. I don't think we'll need to move them up a lot. So here's the object we're looking at. It's a kind of a unique cluster, isn't it? Sort of V-shaped. Let's go over here to our planetarium software. It's called Stellarium. And you can see that we're pointed almost due east, maybe not quite, somewhere between southeast and east. So there's the bearing, the azimuth. It would be around maybe 100 degrees azimuth, so just past 90 degrees east. You can see we're up something like 20 or 36 degrees actually. 36 degrees up in the sky. And if you're looking for constellations to get oriented, here's the Orion constellation with those famous 3 stars in the belt, and the shoulder stars, and the feet down here, the bow and arrow that Orion's holding in his hands. Well, right above Orion this time of year is this bull, Taurus. And I wondered what this bull would look like. I put on some artwork here, and you can kind of see these are the 2 horns of the bull. And Taurus actually, I think, shares a star with Auriga, this corner star. And the tip of that horn is actually a shared star, you see. Well, if we get rid of that constellation arc, because it kind of gets in our way, let's get rid of the actual constellation lines and labels. So we can see here now and zoom in. Here's this V-shaped constellation, or V-shaped cluster that we're looking at called the Hyades. Now, you can see this cluster could actually encompass maybe a few extra stars other than the ones we have in our pretty wide field view. Our RASA field of view is maybe 2 degrees and 10 arc minutes wide, maybe about a degree and 25 arc minutes high, something like that. I don't know. A degree and 27 arc minutes high. So we can get almost the whole Hyades cluster in here. That kind of gives you a picture of where we're looking at in the sky and what we're looking at, and that's the Hyades cluster. Now, if we want to do this observation here, I wrote, on our 100th night of observing while sharing in our 150th video live stream, we launched the evening with the Hyades. I'm not actually sure that we've ever observed this cluster before. So let me see who's with us tonight. There's Ricky. Good to have you back, Ricky. I think you're from Florida, if I remember right. What's up? Well, the Hyades are up, Ricky. And then we've got Bleb Boy. Good to have you here, Bleb Boy. I don't remember where you're logging on from, but it's great to have you. If you don't mind telling us where you are. And then SWI Imports. Good to have you aboard from Australia. And John, good to have you here for day 2, the second of 2 nights in a row. We observed last night and used the secret deep list last night. John, if I remember right, you are perhaps also from down in Australia, are you? I should remember that, John. So sorry. Ricky, yeah, good to have you aboard from Florida. We have about a dozen or more on. There's Kim. Good to have you aboard, Kim, also down there in Australia, I think, as well. And it's an honor. It's an honor to have you, Kim, here in the middle of your daytime, huh? Your morning is getting started. Jeff, hello from Concord, California. Good to have you all here. Over a dozen of you now, and I'd like to welcome you. Thought I ought to read this opening couple of paragraphs from Stephen James O'Meara's book about the Caldwell objects, because his description of the Hyades, Caldwell 41, is particularly picturesque, if you'll track with me here. He starts out this article like this. Nightfall has a mystical feel to it in late December. The sky shines like black ice. Trees look dark and skeletal, and the stars seem to shiver in the crisp winter air. Look halfway up the eastern sky, and there is the haunting glow of the Pleiades, a cluster of hot young stars shrouded in mist. Just above the horizon, mythical Orion throws a leg up over our fence of mountains, to paraphrase the great American poet Robert Frost, and slowly vaults into view with athletic grace. Sandwiched between these two stirring sights is the Hyades, a bright and alluring V-shaped arrangement of stars that sky watchers have pondered since the dawn of history. Now, isn't that just beautiful? Can't you just sort of lose yourself? You're watching a live view, by the way, through our RASA 11-inch telescope, and that's a picture of the scope we're using. You notice it's sitting on an iOptron CEM70G mount, which is on top of a little mount extension, which is on top of an adjustable height pier made by Pier-Tech. And down there in the lower left, you can see that little black box. It's a rack of sorts, a rig rack we could call it. It has all the electronic distribution boxes that turn the 110 volts into 12 and distribute the 12 volts to the different devices. And there's also a box that takes the data from the camera and turns it into the kinds of signals that fly across fiber optic relay cable. And we're actually indoors, about 200 feet away from the observatory, but that camera, it's a ZWO ASI2600MC Pro on that Octopi-Astro camera interface, which is mounted on that glass corrector plate out at the end of the RASA. And that primary camera, that ASI2600, is sending its signals through that, I guess, fiber optic cable all the way into here so we can see it real time. Also on top of the scope is a ZWO ASI178 monochrome camera, kind of a companion camera that lets us show you these views of the sky so we can kind of stay connected. Over there to the right, you can see the 63% moon. And down there at the very bottom of the screen, you can see the building that I'm in. And that's a live view. And if you look closely in the corner, on the far right corner of that building, there's a window that's got some light behind it. That's the office that I'm in, kind of viewing what the telescope is seeing out there in those 29-degree cold temperatures. Well, that sensor is on top of this little equipment plate, kind of a little outrigger on top of the scope. Those two blue boxes. The top one is a little power distribution box made by Pegasus Astro, and underneath it is a USB distribution box, also made by Pegasus Astro. Well, all that data is flying back through this rig rack, through those fiber optic relay boxes, and coming back to us so you can see real time this setup. And there's a picture that's live of the telescope. Tonight, we're trying a little bit different approach. We're using almost a night vision view through camera. There's no infrared shining on it. There's no red LEDs. Over there on the wall, you can see the motor that throws open that rolling roof that rolls off the top of the observatory. There you see it rolled off, and the telescope is raised up in its present high position. Well, that motor, you might be seeing that motor has a tiny little green pilot light on it, and that's illuminated on that corner, on that wall. But other than that, there's no light in the observatory. The only light that's there is the 63% moonlight, and our night vision camera is watching the scope. As you can see, it's pointed east. The camera views the scope from behind as if to look up toward the North Star, you see. So the camera's pointed over toward the right, toward the east, and that's the live view that the camera's gathering through that 11-inch RASA. So, looking here at Omir's article, he goes on to write about the Hyades and talks about the Greek mythology and the Roman mythology of it. He talks about a star that's very close. He says there are about 1,000 stars before Hipparchus' data were released in 1997. The distance of fewer. Oh no, trying to figure out how many members might be in the Hyades. It's at 151 light years away. Trying to figure out how many members it might have. Anybody know that offhand? SWI imports, it's 12.07. Ah, John, New Mexico. Sorry, I wasn't very close at all. The Bloodstone. Good to have you from Zion Canyon. Wow, I bet you've got dark skies there. Trying to figure out. Anybody happen to know how many members we've got in Hyades? Is it 80 or is it 100? Anyway, he writes quite a lot about the Hyades. He talks about how many naked eye double stars there are. Makes kind of a game out of resolving those. Anyway, this is the Hyades, and I think it's about time that we observe this. For some reason, Herschel never cataloged it. Isn't that odd? So it doesn't have an NGC number. Not even his son, John. Neither William Herschel nor John Herschel cataloged it. So it kind of, in a way, surprises us, doesn't it, that it would go unnoticed by them? Maybe it's because it's kind of a loose cluster. I'm not seeing how many members, but I'm sure somewhere in this article he does mention how many stars are in this cluster, but I'm not seeing it. Anyway, it's 151 light years away from its center of mass. 151 light years. So we'll finish out our little observing here. We talked about reading Omir's article. 151 light years distant, beautiful V. And then when we click OK, that object will disappear from our targeting software that we have here. Deep Sky Planner is what we use to kind of give us a guide to go from one object to the next. So we'll rerun, and you see we're picking up a few more objects as we go, as more of them are rising. So let's go back over here and snap a picture of this. We'll just save it as seen. And then let's, you know, one thing I wanted to do in the sequencer, I wanted to see if, let me make sure this is the right one. This is the sequence of things, yeah, next target cycle. I wondered if there's a way, is there a way to prompt SharpCap, which is the imaging software we're using, to do a reset of the side histogram, what we're calling the display histogram. So let's, maybe you guys know this more than I, what we're looking for. Let's go up here in this search and let's put in the word histogram. Nothing there. Let's put the word reset. Reset the display stretch, that's it. So we want to include this in our sequence. Let's reset the display stretch maybe right before we start live stacking. So I forget now, how is it we do this? Just drag this over, right? So we're gonna reset the display stretch right before we start live stacking. So I think we need to restretch it there. Let's try that, because with this new version of SharpCap, I notice I'm having to reset that every time. So now I'm going to look over here and say, boy, it's not letting me save there. So maybe it, oh, here we go. We can save it up there. Now then, let's start our sequence and next target cycle. So what it does is it asks us for the name of the next object we're going to. And let's find that out. It should be the next highest object, 26 degrees, would be C65. So we'll right click there and we'll say show that in the chart. So what it's doing now is it's queuing that object up in Stellarium, and then we'll also slew to it. So we're slewing to C65. C65. So I'll put that as the target name while you guys are watching that slew at the scope. C65. And then we'll also come down here on the title, and we'll change the title to C65. And I don't know whether it has an NGC number or not. I'm going to check the boy, it was discovered by Herschel. Oh, NGC 253, I guess. Yeah, NGC 253. So we'll put that in parentheses, NGC 253. And this is a galaxy in Sculptor. And let's go back to the live screen now and say, yes, it's settled. And let's go over here to our planetarium software and see where we're aimed. Look, there's the side of the observatory, so you can kind of get oriented. And there's the truck that I drove here tonight. It's about 20 feet away. There is the realistic, photorealistic horizon. We keep our trees down below the more accurate polygon of the horizon. So this line, we actually shot this line with the scope. So supposedly, if we've mounted this thing correctly, that's our horizon line accurately. And then the trees, you can see they roughly match that horizon line. We keep the trees a little bit below that line because I don't think the trees are as accurate. And besides, it lets us see what's rising. It lets us see when an object is rising. But Sometimes, like over here, you can see the way we transparencied out the sky. Sometimes the trees take on a little bit different, weird shape. So we kind of like to use the polygonal line as our horizon. So there you see where the scope is pointing. By the way, there's the moon, and you can also see Jupiter right by the moon. So let's zoom in now. Now that we kind of know where we are, boy, this is a beautiful galaxy, isn't it? The Sculptor Galaxy. It looks like we're looking at it fairly edge on, doesn't it? Look at that beautiful core. How about that? There's a nice little cluster here, NGC 288, a globular cluster. I don't think we could get that in the same frame. It's just a little bit too far away. So let's kind of leave things as they are. The Sculptor Galaxy. And I'm looking here on our comments, and there's Kim letting me know that was NGC 253. I should have just looked there, Kim, and you would have told me. Jeff Norman, good to have you here. You're not much late. Good to have you there from Phoenix. I bet it's warmer in Phoenix tonight. It's currently 29.8 here, but I have a feeling in Phoenix it would be much warmer. Now, looky there. I don't think that reset really worked very well. I must have put it in the wrong place. Because watch what happens. I'm going to go up now and I'm going to reset this display histogram. Well, it's not much better, is it? Well, let's just tune our color balancing here. I guess it's because we have our blacks pushed way over here with the last object. So that appears to be what went wrong. Now this is strange, isn't it? That almost looks like a bank of clouds that went by or something. But there's that galaxy. Let's zoom in on this now, and we'll get to about 100% of our APS-C frame, and you can see all those clouds kind of shaping up there. I'm going to move this black level a little bit more toward the sky. You notice, remember, we're going to have moonlight that's you know, kind of being cast. Look at the way the moonlight's going to cast its light pollution. It's like nature's version, God's version of light pollution, you could say. And that's going to cast a little bit of its light. And then over here there is a little bit of light pollution from a little light dome here. Most of our light is over here in the northwest, but there's a little bit of a light dome here as well. Bortle 5.5, maybe 5.5 skies. So we're gonna see some light pollution in our image along with the moonlight tonight. But you can see we're already starting to pick up some of those outer spirals, aren't we? Look how broad that's starting to get. Again, let's look back at Stellarium and see how these outer spirals make a really nice outer ring. And then you've got all this dust gas being illuminated here in the middle ring. And there's the little hub, the little core of this galaxy. And you can see right here, there's the little core. And there's a star, probably a foreground star, that's there in front. Sure enough, that's a star that is called, I don't know if we have the name of it there, IAU Constellation Sculptor, but it doesn't appear we have the actual Hipparchus name or any other name of it. But that's a foreground star, just kind of, you know, getting in our way of seeing a good view of the galaxy. So I don't know where that foreground star is. It could be this one maybe, but either way, that does look like it's the hub. And look at those outer gaseous spiral arms that are being thrown out. We're going to boost those mids up a little bit more, see if we can bring up a little bit more of that color. Sure enough, now you can see a little bit more of it. We're using a technique, obviously. I mean, you guys are all pros. You've been doing this. It's electronically assisted astronomy. We're stacking the frames here. That's what this live stacking does. We've got 4 minutes of integration so far on this RASA. It has a focal ratio of 2.2, so it drinks in the light fairly fast. Let's see what Stephen James O'Meara writes about this. He says, stunning, spectacular, incredible. So many adjectives have been used over the years to describe NGC 253 that it's difficult to find others more appropriate. He says, in photographs, the impression is one of magnificent animation, of clumps of starlight and dust stirred together in a stew of galactic vapors. At a glance, the galaxy looks like the beginning of universal order emerging from simmering chaos. And, in a way, it is. NGC 253 is a somewhat normal, somewhat barred spiral. I don't see much of the bar there. Maybe it's because it's kind of end on. I bet we're looking at it from end on. With a complex lens centered on a tight central core that has some of the densest knots of stars ever found. A bar cuts across the lens and is encircled by a bright elliptical ring of stars and dust, off of which fly two spiral arms, one to the northeast, one to the southwest, like two propeller blades. And William Herschel put it in his catalog of new nebulae. It was actually discovered, William says, by his sister Caroline. So he gives his sister proper credit. And she had a 27-inch focal length, small Newtonian, and he marked it CH temporarily with her name. Go Caroline. And then William's son, John, observed it high in the sky from the Cape of Good Hope with an 18 3/4 inch speculum metal reflector, and he began to describe it in greater detail. So it lies about, what would you guys say, maybe 9.8 million light years away. That's a good little piece, isn't it? 9.8 million light years. What a beautiful, beautiful galaxy. Has sort of a three-dimensional nature because we're looking at it edge on. Compact clumps, stellar associations. Star-forming areas. 9.8 million miles. So let's do an observation of this in Deep Sky Planner. This also serves a double purpose. It lets us keep track of which objects we've seen, and this is our first time to ever observe this object. So NGC 253 is fairly edge on, but three-dimensional. Beautiful knots of stars and gas, star-forming regions. 9.8 million light years distant. It's remarkable that Caroline discovered this back in 1783. Is that 250 years ago? Almost to the year. Wow. And we're looking at it when it's up around 25 degrees, so not incredibly high. Let me do another color balance. Colors might get weird there for a second. We'll bring our black level over just a little past the crest, and that'll pick up a little bit of sky glow. I'm going to hold down the shift key so when I move this bar I have a little more fine-tuning control of it. We'll get rid of just a little bit of that sky glow, but look how much more of the object we picked up when we move that black level into the sky glow a little bit. Now that's 100% right there. Isn't that a beautiful view of this galaxy? Now remember, this is not a picture from the Hubble. This is live. This is live. Jeff Norman, 63, maybe that's degrees in Phoenix. Arizona winters get cold. Yeah, we're really hurting for you, Jeff. 63 degrees. So that picture is back to front. It might be. We do have, I think, it inversed, yeah, a little bit. Look at that hub. Man, I'm having a hard time pulling myself off of this, but let's do. We're going to save this now exactly as seen, and we're going to say goodbye to NGC 253, otherwise known as C65. I'm going to check our sequencer here one more time and see if that, yeah, reset the display stretch. It just seems like that wasn't quite in the right place. Tell you what, let's do. Let's move it down here right before we reset the live stacking. Let's try it there. So we're going to save it again. And I'm just trying to automate that process of clicking that little reset over there so I don't have to remember to do it every time. Okay, here we go. We're going to run that sequence that we were just programming. Next target cycle. Okay, let's go over and get our next object, and that would be, let's run this again. Looks like we have a globular cluster at 21 degrees, and that's C25. So we'll set our stellarium star chart on that. We'll slew to it. And again, this is C25. So put that name, C25. And we'll also come down and put in the title, C25. And I wonder if this has an NGC number. I don't see one there. We'll look this up in Omira's book. I don't see it in Deep Sky Planner. NGC 2419, it does. NGC 2419, and this is a globular cluster in links. No connection to LinkedIn. Are those clouds starting to form up there? Those rascals. Let's go to our SkyCam. My goodness, they are, aren't they? That's so sad. Those clouds weren't supposed to come in until after midnight, but they've made an appearance early. Rats. Well, we'll go as long as we can before those clouds knock us out of commission. So yes, the mount has settled. And now let's go look and see where we're looking here. Oh wow, that's beautiful. The Intergalactic Wanderer. I've heard of this before, but it doesn't look like we've ever observed it, strangely enough. Again, you can see the side of the observatory. We're looking in the northeast direction. You can see we've got a couple of trees that are up kind of high here. If that's at 25 degrees, 21 degrees, you can see it's between these two trees. And that must mean these trees are, you know, there's the exact horizon here. So these trees are up every bit of 17 or 18 degrees, these two trees here. We're going to have to get a chainsaw one night when our facility manager's not looking. Mike, good to have you aboard. It is observing night number 100. Welcome, good to have you here. So anyway, that's the part of the sky we're looking at. Let's zoom in on the Intergalactic Wanderer. Look at that. Looks like a beautiful globular. Nothing else in our frame except for this little NGC 2424 here, which is a radio galaxy. How about that? So that won't even be visible to us, will it? Huh. Let's see if we can find that. So look, here are two stars in a row, and that's a double. And actually three, if you count that one that's a little bit crooked. Rascal 77, don't murder the trees. Okay, we won't. I was just kidding. There are two in a row, so this makes a belt like Orion's belt. And then off catty-cornered like a hockey stick would be NGC 2424. Let's go back to our live view. Now this is the live view. Oh, look what happened. That reset of the display histogram worked this time. Thank goodness. So let's bring our black level back over to here where these crests are. Oh, rats. We're going to have to hit it again, aren't we? Let's reset the display histogram again. There's that glob right in the middle. Now, built into our cycle is a plate solve. So typically, the scope is reading all of these stars and comparing them to a kind of an encyclopedia of star images, and then realigning itself and also syncing itself every time. That's just built into the sequence that we use. Really fun and handy now that it's built in. So there you see it. It's right in the middle there. Let's see if we can make it a little bit brighter. Bring it up just until, that's 120 seconds, so that's just 2 minutes. Now here are those two stars. Remember this one was double? We said you could say there are three if you want to use all three, but these three would look like Orion's belt, remember? So now let's back away and let's see if we can figure out where that, well, I'll tell you what we could do. If we could see if by chance we have in our deep sky image annotation, there it is. So our deep sky image annotation is pretty much right on track. There's NGC 2419. It's just slightly off to the north. There goes a little cloud, by the way. So let's look somewhere right in here. Yeah, I think we'd have to have a radio telescope to see this, but right there is this radio galaxy emitting, radio waves, not visual waves. There goes another cloud, rats. Those are going to become bothersome, aren't they? We do have our sigma clipping on in live stacking. You guys are, I'm sure, aware of what that does. It looks at images of light that aren't consistent every time a new frame comes in. And with sigma clipping on, what it's going to do then is drop out the ones that are not consistent. And it's designed for things like satellite trails and airplane lights, so that over time it will diminish those. But it never really diminishes them all the way. Once this cloud snuck by and left its trail, it's going to be kind of hanging around for a very long time, at least very long in the scale of what we use with electronically assisted astronomy. Now, an astrophotographer might take a 6-hour picture of this in order to collect enough frames to stack. But in EAA, we typically only stay with an object for, I usually shoot for 7 minutes. I don't quite make it because I'm always trying to go to, Stephen James O'Meara's book here or something and read about this. Of the 150 or so globular clusters known or believed to be associated with our Milky Way galaxy, NGC 2419 is among the most remote. In 1918, Harvard College Observatory astronomer Harlow Shapley began determining the distances to these spherical swarms, each containing tens or hundreds of thousands of ancient stars. He found that globular clusters appear to be distributed within a sphere of 65,000 light years in radius that was centered on the galactic center, the Milky Way galaxy center. This significant discovery demonstrated our sun was not at the center of the universe as many had previously believed. Shapley, or Shapley, I don't know how you pronounce that, knew that NGC 2419 was a distant cluster and assigned it a distance of 99,000 light years. But it was Walter Baade, B-A-A-D-E, who first discovered exactly how extremely distant it was when he put his Mount Wilson Observatory telescope on this image, and he found that it was 182,000 light years away, about as far as the Large Magellanic Cloud is, the Milky Way's preeminent satellite galaxy. You guys in Australia would know about that. Mike says, not a diffuse nebula, but beautiful. SWI Imports, he laughed and said, I was going to say, time to cut the trees down. Yeah, for sure. He gives a little more history, but let's remember this. This globular is 100,000 light years more distant than the Large Magellanic Cloud. So it's out there farther away from that. It's farther away than the Large Magellanic Cloud. Some astronomers understandably refer to these extremely distant globulars as intergalactic wanderers. And though the common nickname for NGC 2419 is the Intergalactic Wanderer, just There are several others who might be called intergalactic wanderer. Some are called intergalactic tramps. Oh, that was the original name that Shapley gave it, intergalactic tramp. That's kind of fun, isn't it? But it wasn't quite as politically correct as wanderer. You can see that. Is it lost in space? No. It is securely bound to the Milky Way. Beautiful. So, in summary, 275,000 light years now, it is thought to be. 275,000 light years away. Let me get rid of this 270,000 light years. At 275,000 light years distant, we might have assumed this intergalactic wonder isn't a part of the Milky Way. After all, remember, the Milky Way is only 100,000 light years across, maybe 150. So this is way far away from the disk. But the data say otherwise. One of our farthest globs. A beautiful sight with its companion belt stars. Beautiful. Caldwell 25. Okay, so we'll take our picture and oh, did we want to edit the sequencer or was that better? We still had to reset it again, didn't we? Is that right? I'm trying to remember. We had to reset it after let's try it down here. After we do the auto white balance. No, let's do it right before we do the auto white balance. Okay, let's try it there. Searching for just the right time to automate this little step. Okay, here we go. Running the sequence for next target cycle. We're going to go back over here to our targeting software, Deep Sky Planner 8, and do another, when you use the word run with Deep Sky Planner, it really means like refresh. So looks like our highest galaxy now is at 20 degrees and it's C67. So again, we right click and show that in the chart, right click and slew to it. C67, we'll put that in as the name, C67. And we'll go down here on the title on the screen, C67. Looks like it's got an NGC. Has an NGC number. NGC 1097. NGC 1097. And this is a galaxy in C67. It's a galaxy in, drumroll, Fornax. A galaxy in Fornax. Again, the first time we've ever observed this as well. Look at those clouds you can see now in the scope cam, and look at them in the sky cam. Ugly things, look at them. Sneaking in on us. Rascals. Okay, so we'll say the mount has settled. We'll go over to Stellarium and figure out where we are here. Okay, we're looking just east of due south at 20 degrees above the horizon. So let's look and see what Fornax looks like here. I don't have that constellation memorized. No wonder. It's 2 stars. There's Fornax. Oh man, how are we going to learn that? Let's look at the constellation art. Looks like it's a little stove, doesn't it? I don't know if that's going to be that helpful. So let's remember that it's kind of below Cetus, the whale, and it's kind of surrounded by Eridanus, Fornax. Here's our field of view, by the way. This red rectangle is calculated so it represents fairly accurately, we hope, the field of view that our RASA is seeing through this ASI2600MC Pro camera with that APS-C size frame. So you can see we're looking at a barred spiral galaxy here with an interesting dust trail that looks like it's been interacted with. I wonder what this thing is here. That's just a star. Who knows? Looks like a fairly small galaxy. Okay, so I don't really like the way this turned out, but maybe it's better than it was. By the time we do our color balance, we might actually be looking at things okay. Yeah, I think it's all right. So we've already got this object in view at just 60 seconds on a moonlit night. Let's see what the moon is exactly. What is it? Oh my. Oh wait, that's Friday. I'm looking at an object weather in England. For those of us here, it's 66% right now. 67% moon, and still in 60 seconds with EAA on a RASA 11, we're able to already start seeing this object's shape. Now it's very grainy, I grant you, and not very pretty so far, but it looks like it will be, doesn't it, in time. C67. Let's open up our observing window here. And let's read about C67. A prominent member of the Fornax cluster and the Eridanus cloud, NGC 1097 is a fantastic example of an X-ray luminous Seyfert galaxy. What? What is an X-ray luminous Seyfert galaxy? Photographs show how an extremely bright nucleus burning at the center of a broad dusty bar, while 2 magnificent star-studded arms sweep out in opposing arcs. NGC 1097A lies just beyond the bar's northwest tip, where the spiral southern arm suddenly frays like an old rope. So it has been interacted with. So I wonder if this is NGC 1097A right here. Yes. Look at the way the interaction of this little galaxy with this bigger galaxy has pulled apart those spiral arms because of the tidal, TIDAL, the gravitational, tidal gravitational attraction. And it's warped it, like you see in, what is that, Whirlpool galaxy, M51, right? It's warping it. That is so interesting, the way these two are in a kind of a tango. And even though this little tiny guy is such a tiny guy, he has made such an impact. This tiny nucleus is an extraordinary energy engine. By the way, remember, you're looking at a live picture here. We have about 16 people on the live stream. That's awesome. Thanks for being here, everybody. This is a live picture. This is not some kind of planetarium software. This nucleus emits about 1,000 times more energy than our own galaxy's hub or core emits. These Seyfert galaxies tend to be in tight binary galaxy systems. So we think this is the binary galaxy with it. We think these two are interplaying here, interacting. And these Seyfert galaxy hubs emit quite a lot of energy. Two pairs of optical, that is visible light, jets have been detected, extending as far as 15 arc minutes from the nucleus. Now he's got our attention, doesn't he? Let's pull up. I'm going to hold my shift key down so we can fine tune this black level. Let's pull up that black level as far as we can. And then let's bring the mids up until there's just too much grain. Now let's zoom in digitally. So we've passed well past our optical zoom. I was hoping we could see something of a little spur. You know, I almost think here on top, there's a little bit more structure here on top. We're only at 5 minutes, but I'm kind of imagining in the corner of my mind that up here on top is this little spur. So that's a jet. Is it safe to look at? I think it's safe by the time it gets here. X-rays. That's awesome. You've been to the dentist too much, Mike. They put that lead apron on you too much. It's the most extensive system of optical jets known to originate from any galaxy. But a guy from the Anglo-Australian telescope, down there your guys' way, down under, 3.9 meters, a couple of guys like David Carter have studied it, and they don't think it's that kind of jet. They think it's a thin, tidal tail formed during the capture of a low-mass galaxy. It's because the Einstein satellite detected such strong X-ray sources around these jets that he doesn't think they could be visible lights. 6 of these have been identified as quasars, which are very powerful, huh? Wow. You know what we ought to do? It's a very large galaxy, by the way. 123,000 light years, so about as big as the Milky Way. 200 billion suns. Let's write that down. Where's our little, here it is. NGC 1097 is 123,000 light years across, but has a mass of 200 billion of our suns, making it a fairly good match for the Milky Way. $47 million light years distant. Tremendous X-ray source. You know what we ought to do? We ought to go look at this in like a Hubble photo. So everybody brace your eyes because it's going to be very bright. We're used to looking at all these darkened, darkened images to kind of preserve our vision to see these very faint things. So you might kind of look away or kind of shield your eyes. We're going to go look for NGC 1097 NGC 1097. Now this is when the bright light comes. NGC 1097. Bam! Isn't that bright? We'll get this object up here as quick as we can. Wow! It's beautiful, isn't it? And this is 1097A that's interacting with it. You can even see the barred nature of that, or else it's an elliptical of some kind. But look at the way this nucleus is just filled with those blue stars and light star-forming regions. Look at all of these young stars. All these blue stars would be young. Now you can see the bar and this whirligig nature that's being thrown out. This is this area that's been frayed. You know, the spiral arm that's been torn apart. So now let's go back to our live view. Here's that spiral arm. Let's see if we can brighten up that spiral arm a little bit more. Just a little bit before we start picking up grain from the entire scene of moonlight. Look at all of this trail that's been attracted by this 1097A. Let's do our save exactly a scene image of this. It's a beautiful little galaxy, isn't it? We could easily see the frayed arm impacted by NGC 1097A. And we thought we might be able to make out a little more structure toward the top side, which might be a hint of those jets that are oozing out of this galaxy's core. Very interesting. And that's just 11 minutes of integration. Really cool. All right, let's head to the next object, and it looks like if we run this again, we have a diffuse nebula at 20 degrees that we've never observed. So we'll sync the chart to it. We'll slew to it. I thought Stellarium had crashed a while ago. I was kind of embarrassed that it had. So I quickly, I quickly jumped off of it. We should be matched with it. So there you see the telescope slewing. And then if you come back here, you can see the telescope moving into view. See how Stellarium tracks the location of what the telescope is looking at? Kind of looks like a satellite moving across the planetarium software. Look how we're right in the middle of a bunch of clusters. And this is going to be a diffuse nebula there. So again, looking at the scope, you can see we're angled down at the horizon now, just 20 degrees above the horizon. So I hope we're free of these trees. It looks like we're right in between these two trees. That's a good thing, isn't it? The horizon is lower here with smaller trees. So again, this is the edge of the observatory wall. You can see the observatory door that we left open in this picture. And we're looking out across that corner toward the east and looking up about 20 degrees toward the east. And this is in the constellation, is that Monoceros? Monoceros, yes. And Monoceros, if you'll recall, is actually like kind of like a unicorn. Has just one horn, Monoceros, mono. So there's the artwork. Whoops, you're not seeing that. There's the artwork. So you see Monoceros is this unicorn. And let's get rid of that now. And so here's the stick figure constellation of Monoceros. And looks like we're here with this Christmas tree cluster, an entire set. This must be a rich, Milky Way portion of the sky. Oh my goodness, this is the Rosette Nebula. C49-1, I just didn't know it by this name. C49-1, the Rosette Nebula. Okay, so surely we've observed this before, but not maybe under this name. And that's why it didn't have it. So let's go back now, and the name of the object is C49-1. And it's definitely settled. C49-1. While that's live stacking, I would like to just do a fun look back. Let's go to YouTube. Since this is the 100th night observing, and why isn't 1097A torn apart? I don't know. That's a good question, Mike. I guess maybe it might be, and we just can't see the gases that have been stolen from it. You remember all that we were seeing that was left over was pretty much the bar. So maybe it got torn apart in that 1097 robbed it of all of the spiral gases that it used to have. Let's go to our YouTube channel. That's a good question though, Mike. I'm glad you asked. And let's first look under the live streams. And let's take a trip back memory lane. Since this is the 100th night of observing, this kind of becomes a bit of a record of our journey in astronomy. You see how this is actually in December of, it says a year ago, December of 2021, would it be? But I think that's when we started live streaming. Let's go over here to the videos and let's go back to the beginning of those. Still just a year ago. Huh. So have we just been observing for a year? I guess so. How can this be? Maybe not. Maybe we've just been live streaming for a year. And we were doing EAA before that. Maybe we weren't live streaming it. So back to the live streams. I guess the story of Emerald Hill Skies actually starts in November of 2020. A homeschool group asked me to bring an old dusty 8-inch telescope I had. It was one of those Celestron CPC 800s. CPC, the 8-inch. Kind of like the Altaz yoke with just the Schmidt Cassegrain 8-inch on it. And I hadn't used this telescope since the year 2000, so it had been 2 decades. I tried to get the scope out and took it to these homeschoolers and tried to set it up and show them something. Oh my goodness, not only was I out of practice, but it was a moonlit night. So I tried to show them the moon. The telescope was tracking okay, but every single person in this homeschool group would come up and they just look through the lens for the eyepiece for just a few seconds, and then they would bounce off. And every one of them would touch the eyepiece and get the telescope off a little bit of its tracking, and it was a zoo, to be honest. And finally, one of the homeschool mothers came up and said, "Doesn't it have some kind of screen?" And I thought, oh my goodness, that's such a high expectation. I don't even know if you can do that with the telescope. Can you? And that really raised my curiosity. So I got online and I started reading, and sure enough, guys like Rock, what was his last name? He did the Mellon cam. So was it Mellon? Had begun experimenting with these, I guess they were security cameras. and paired them with scopes. And just as November of 2020 came on board, there were some really less expensive CMOS cameras that were coming out that were made as dedicated astro cameras. And boy, I just thought, I'm going to show her. I'm going to show this homeschool group. I'm going to learn how to do this. And the next month, I sold every single spec of astronomy gear I had. I mean, I sold everything. Observing chair, tripods, all of the paraphernalia you can imagine, the CPC-8, its viewfinders, and everything I could find to sell. And I used that as the bulk of the down payment and tried to collect pennies and managed to scrape enough to buy a RASA 8-inch with a Skywatcher EQ6R Pro mount, EQ6R mount and tripod. And really that's what we first started live streaming with in January 12th of 2021. And you notice we call this learning mode, and man, it sure was. We actually operated the whole thing, the whole rig from inside of a truck. And if you go to our website, I think I think we've taken it down now. The website is Emerald Hill Skies. Yeah, we've taken it down. I used to have a picture here of that long time view, but it looks like we've taken it down, sadly. A picture of me operating, you know, out there on the road from inside the truck with the motor running, trying to keep warm in the middle of the winter with a 20-foot USB cable going out to the scope. And Larry Fraley says, you should get a Stellina. Larry, you are exactly right. It's lots easier, isn't it? And more portable. So that was a beginning. I think that might have been our first live stream. And you can see at the time we're using BlueStacks with Sky Safari, and we were using Astro Planner as the targeting software. These were kind of some specialty streams that we did. Fumani, good to have you here, Fumani. It looks like your name is Mario, and you're saying congratulations on 100 nights of observing. You are since the 2.4 thousand stream. Oh, you're talking about the time we did those meteors. They called it the meteor storm, aren't you? So nice you're here. Keep up the good work. Looks awesome. Into space. Thanks a lot for the outside view. You're very kind. Little by little, we began to try to clean things up. We started doing this look of this black sky. That was still around a year ago. Started putting the title up at the top. Did an initial logo. In this, you can see the scope is at least outside. We always had a little blanket. And these are still, now I put the date on there. There's September 10th, 2021. So that's more than a year ago. This roughly a year ago must be like a rounding up, you know, or something. So little by little, then we made friends with a bunch of people and started doing, you know, these Messier marathons together. That helped us learn a lot. Thanks to those guys. And here we were still operating outside. And here, about 8 months ago, we finally got the observatory up. This is a 9-hour live stream of the build of the observatory about 8 months ago. And finally, we got the scope in the observatory. This was the first night of observing. And you can see little by little we're picking up. We did another Messier marathon, this time from the observatory. We started doing this Caldwell list and other kind of guides. And boy, it just feels like everything took a real leap forward through all of you guys who are friends. Now this is the night that we did those Tau Herculids meteors. It was supposed to be a meteor storm. And this video went to 104,000 views. And Mario, you're remembering, we would have like 2,500 people on at once. And remember that, Mario, the comments were going by so quickly, you couldn't even read them. They were going by so fast. Many of those people subscribed, which brought us to 3,700, I think, subscribers, and we've stayed at that since that night. Started doing a few more of these lists from Steve and Omira, and that brings us to the 100th observing session. Also, YouTube now has separated the times when you do a video as a recording. So these are the ones I did as a recording, and here's this video you can see where we're operating outside on the road. Can you make it out there? Probably tiny on your screen. But operating outside on the road with a little blanket down on the road. Had our truck parked beside the telescope. Here is a few of those recordings of the... And then along the way, we went from an 8-inch, when we got the observatory, we upgraded to this 11-inch RASA. Here's the night, the first night that we used the 11-inch RASA. And went to the iOptron CEM 70G mount and started operating indoors. Got that movable, the adjustable height pier, and then this wall-mounted monitor so we can operate from inside the observatory. So that's kind of been our journey, and I thought that would just be fun. Mario says, oh yeah, it was the meteor shower. We just see a couple, but start to see many things. It was a great night, a great stream. You're very kind, Mario. That's right. We didn't see very many meteors, but a lot of people tuned in case we would. It really worked in our favor. So that's kind of what we wanted to do, you know, kind of memory lane style on this 100th night of observation and 150th recording that we've done. And thank you, many of you all, always within it seems like within 3 days, we always have 200 or 300 people that are viewing the live stream. And all I can say is thank you so much for being a part of this. It really does mean that astronomy is no longer a solo thing where you go look through an eyepiece by yourself and it's kind of creepy. You're out there by yourself, maybe in a field or at the edge of a woods, and you know, you're kind of sitting out there lonely and you hear a noise over in the woods and you wonder, is somebody about to, you know, haunt you? Looks like, Mario, you're from down in Monterrey. Entonces habla español. Gracias por venir. Lots of good and great vibes. Keep up the good work, and thanks for your time. Thank you, Mario, for being a part of this. You know, now we can observe from inside here. It's shirt sleeve temperature, even though outside it's currently 28 degrees Fahrenheit. That's below 0 Celsius, of course. Wow. We're so thankful for this setup. Okay, let's go back now to the object, this diffuse nebula. It's C49. Let's change our title here. C49, and we're actually looking at 49-1. And the NGC number, I don't think it has an NGC number, does it? Yeah, it does. NGC 2238. You know, if I remember right, the NGC number is actually the NGC number of the cluster rather than the diffuse nebula. So we'll go ahead and put a diffuse nebula in Monoceros. But if I remember right, that NGC number identifies the cluster rather than the diffuse nebula. Now you notice with a typical scope view, you might see this. It's a very dim cluster. But let's bring our blacks down here, and you can start to see it right away, can't you? And let's reset this display histogram one more time, and let's do a color balance one more time. Now remember, this is on a night with 60% moonlight, and the moon's still bright. Here's our sky cam, and the moon's still bright over here at the edge. Let's see, the moon doesn't set till after midnight. So it's still up there. But in spite of that, we're seeing quite a lot of this. Look at that. Isn't that amazing what this RASA can do? F2.2 is just an amazing thing, isn't it? Now you notice it's a little off-center, isn't it? And yet I think we can make out most of the nebula. Let's look back in Stellarium. Yeah, we could have seen that, huh? Because there's our RASA. For some reason, we could actually recenter it, but we'd have to start restacking, and I'd hate to lose the 13 minutes of integration. So let's don't recenter. But this shows us that we should look at the framing, shouldn't we? Where the RASA is centered, we should look at the framing and make sure we have our objects centered before we get to live stacking. We were doing this walk down memory lane. Dennis, that's so nice of you. I think you're out in Colorado. 100 nights of observing. You're very kind to encourage. It really means a lot. This diffuse nebula is being lit up by this cluster. And the NGC number is, I think, of this cluster. But look how much nebulosity we get. And that cluster is just powering up all those clouds. Again, this is C49. So let's glance at what O'Meara says at this. He has quite a lot about it. The Rosette Nebula, the Great Nebula in Monoceros. Some people call it Swiss Nebula. This is a little clip that I use. It's actually a giant paper clip. One of the heaven's most obscure constellations is dim Monoceros. It's a sprawling array of inconspicuous suns east of Orion. Of its more than 60 naked eye stars, none shines brighter than magnitude 3.9. So it's kind of maybe average in its starlight. The constellation is as elusive as the mythical unicorn it represents. But halfway between the unicorn's nose and eye, and just a jog to the southeast, we find the Great Nebula in Monoceros, Caldwell 49, one of the largest and most massive nebulae in the night sky. Better known as the Rosette Nebula, this wreath-like network of dust and gas is about as large as M42, the Orion Nebula, on the plane of the sky, but it is more than 3 times as far as M42, and therefore that much larger intrinsically. At its greatest extent, the Rosette spans nearly 115 light years, while the Orion Nebula spans only 40 light years. So in other words, in its angular extent of the degrees of our sky, it's the same size. But it's so much farther away and so much brighter, but the Orion Nebula looks brighter because it's a third of the distance. The Orion Nebula is only 40 light years only 40 light years across. It's a snow-dusted rose seen by the frosty light of the moon. How about that for an imagery? A snow-dusted rose seen by the frosty light of the moon. Let's open up our observation panel before we forget that. Incredible way to describe it. The Rosette Nebula is like a snow-dusted rose. A snow-dusted rose seen by the frosty light of the moon. Seen by the frosty light of the moon. And we'll put that in quotation marks and put O'Meara behind it, lest anyone accuse me of plagiarizing. 150 light years across, and I'll put in parentheses, compared to M42 being M42's 40 light years across. It's so much farther away, but occupies roughly the same angular extent. One of the most beautiful sights we've ever seen, right? Wouldn't you guys say that? Mario, wow, always is very magical how start to appear the images and think is just to look up. They're there all the time, just very far away. Mario says it's like magic, and you're exactly right. When we move these bars around and that appears out of that blackness, it's kind of like one of those, I always think of that Star Trek, is it a Romulan bird of prey? The way it just appears off the bow, you know, of the Enterprise. Look at the dust lanes. We could easily see the dust lanes standing in front of the nebulosity. Now this gives this object so much character. Stop and think. Over here, the idea is that that nebulosity doesn't probably stop. That's the theory. That nebulosity doesn't stop. This is dust and dark nebulae in front of the lit up nebula in back. So what we're seeing here is these giant stars are illuminating that nebulosity, and then that nebulosity is acting as a backlight for this dust and gas, and call it like carbon and soot. It's sort of like the soot that gets on the bottom of a dish when you hold it over a candle, you see. And just look at the beautiful picture patterns of that soot. I mean, these are all unique patterns, and sure, they're moving, but they're so far away, they don't really appear to move that much for us. So for our entire lifetimes, we could pick out Rorschach colorblind test nature of these, and it would stay that way the whole time. Mario's asking if we could know the size of the darkness. I guess we could take guesses, but you know, if it's 115 light years across, and we could go back to the full view. If it's 115 light years across, then you could sort of guess, couldn't you, that this river of darkness here might be, what, 2 light years wide, maybe? Down here, I love these patterns down here. They're just so unique, aren't they? And look at the different colors of stars. You've got yellow stars with jet white color stars. Look at these are probably, I bet those are real doubles. Those are probably not optical doubles. Those are probably real live binary systems. But these dark areas are just, to me, fascinating. That look at that jet of darkness that's spewed up there. It's like spewed up there over the top of this background of nebulosity. I mean, you could study this pattern. Mario, tú eres muy amable. Gracias por tu presencia aquí. We could study these patterns here. To me, we could just study this for hours and look at all these patterns and try to memorize this. We could continue to try to improve. Let me mix up the colors again and see if we can improve these reds. Let's come back just a hair and pick off the top of that crest. Now let's back off of the whole thing and see how color balancing it again gives us a little bit brighter color. Now, you could argue, well, what color should it be? Because really, what is color? I mean, Azray, good to have you here. By the way, Azray, you'll notice that in our scope view tonight, we don't have the observatory lights on. It's pitch black out there except for a little wheat grain pilot light and the motor that operates the roof, you know. It's just a wheat grain. So this place is pitch black. But thanks to you making the suggestion, we do not have those red LEDs on tonight. Thanks, Azray. The dust, it's going to form Rorschach colorblind tests. It's going to look like a kaleidoscope as you twist the little things around. It's going to look like, you know, an ink blot test. That's maybe a better way. They're like ink blot tests for us. But look how by doing that new color match, we were able to get a much brighter hue of red now. Now what we're trying to do now is let's try to darken the sky around it a little bit. I'll hold down my shift key so we can fine tune. Trying to darken the sky around it a little bit more so the rose stands out. And what we're trying to do now is bring out the new clouds we're seeing because we've hung around in this object for 23 minutes. And look at this part of the rose that we weren't even seeing before, because this part of the rosette is much fainter. Oh, you're kind to encourage, as Ray, you're an encourager. We're just thankful that you guys are here to observe this with us. But this faint portion, you got to hang around for 20 minutes to see this. I think with this image now, at 24 minutes, we'll call it a night. But I'm starting to say, what color should this be? What is color? Well, color is something that our eyes perceive. It's really just a bunch of spectra. And in this case, it's a lot of hydrogen alpha that's being backlit. What color should that be? I mean, you could argue that it's too bright red now. And so maybe we should tune down the red. So I'm going to come over here on the red slider and say, should it maybe be more like that? A little bit less vibrant red. I mean, you can tell the difference depending on how colorblind you are, right? All right, let's do our shot of this. It's a shame tonight we weren't centered, but I think with some cropping, we'll take care of that and it won't be the end of the world. And then let's do our sequence as a new object. And let's close out our observation here. We were amazed at how much more we can see with electronically assisted astronomy, EAA, especially with Bortle 5.5 skies in the Louisville Light Dome and a 66% moon tonight. It's just amazing. EAA rocks. EAA rocks. Okay, we're going to go over here to our targeting software and refresh our screen. And the next object we have is, well, that's 49.2 and 49.4. It's all the same. It's all the same. It's the same object. Same as 49.1. And 49.4 is the same. It's still the Rosette Nebula. So we'll just add this observation. We'll say C49.1. Just different parts of the Rosette Nebula. Here's an open cluster at 20. Oh, that's one of the clusters in the Rosette Nebula. It is that cluster that's lighting up 49.1, the Rosette. It's all the same. Okay, that brings us to a planetary nebula in Gemini. Let's do a refresh again. Yeah, it's at 24 degrees, so we should be able to do that. We'll show it on the chart. We'll slew there, and it is C39. C39. We'll go down to the title on the screen, and C39, and it has NGC 300 as its number. NGC 300. I don't think we've ever observed this planetary nebula before. It's a planetary nebula in Gemini. Are there two eyes on Gemini? This is called the Clown Face Nebula. C39. Only one eye on the end of Gemini. Only one eye. So let's go down and correct that. Okay, let's go look and see what part of the sky we're in. I'm going to pull our stellarium out a little bit. There we are. You know what? Before we start live stacking this, oh, it won't matter on such a small target. I was just used to how big the Rosette Nebula was. Let's back off and see what part of the sky we're viewing. So again, there's the edge of the observatory. By the way, have you ever noticed when we do a photorealistic horizon, and I have a video about this. Mario is saying, in here apply the red color as older and farther, or was it just the adjustment for the image? Looks like a rose. Yes, you're exactly right. That's right, Azray. C39 is also known as the Eskimo Nebula. Correct. Clown Face or Eskimo Nebula. Thanks. Have you ever noticed when you do a photorealistic horizon, if you're not like a precision engineer, and I've only done 2 or 3 of these in my time. This is probably my 3rd go-round at this. Notice how easy it is to be just a little bit off by the time you shoot the entire 360 degrees around. And I'll redo this someday, but for right now it's close enough for me. But look how the wall of the observatory doesn't quite match. And that's why I tell you, really don't pay attention as much to the photorealistic horizon, because it's just there to kind of give you the sort of the ambiance of the night sky above Emerald Hills. So this way you can see the building, you can see the office where I'm sitting. Right over here is where I'm sitting. You can see, you know, our prayer, our training center here, prayer center and atrium building, and the future spot where our training center will be. You can see all this and kind of get a flavor for our campus, but really this line is the thing that's more exact, because we actually use the telescope itself and we shoot these corners one dot at a time. So this line should be a lot more accurate. You know, Sirius should be right there in that tree right now. If we go look at Sirius, and I'm being serious, it should be right there behind that tree, but this line is the thing that tells us that. And that way it also, by bringing the photorealistic horizon down a little bit, you can kind of see what's going to rise. So Sirius is going to come out from behind that tree in just a few minutes. Okay, so let's go look at this Eskimo Nebula now, and we kind of see where we are, again, right over the east horizon, the east azimuth. Okay, let's go back and let's do another photo balance and another live set of the side histogram. Now let's zoom in on this. We really don't have probably the best telescope for this, because a RASA is such a wide field, and this Eskimo Nebula is only, what? How big of an extent is it? I wonder if we look here under this observation, if it tells us the actual number of arc minutes. Yeah, 54 arc seconds. So this Eskimo Nebula isn't even 1 arc minute. Remember, the night sky can be divided into 180 degrees, horizon to horizon, divided into 180 slices. And then each of those 180 slices can further be divided into 60 slices, which are called arc minutes. And then each of those arc minutes can be divided into 60 smaller slices called arc seconds. Well, this object is only 54 arc seconds, so it's not even 1 arc minute. So just under 1 arc minute of extent. Now, this clown face, I know I've kind of played around with this before. What I think we'll do is bring the mids down in this case. Instead of bringing them up like we normally do, we're going to bring the mids down. And the reason we do that is because we want, on purpose, to let the central star get a little bit dimmer, so we can see the 2 outer shells, because it's the 2 outer shells that make the clown face. Or I think, Azray, you're a little bit more accurate. This looks a little bit more like an Eskimo face inside Azray 2392. Do we have the wrong? I must have corrected that, right? Because it seems like it's correct now, right? NGC, oh, 2392, you're right. It has 300 in the title, and it should be 2392. Thank you so much, Azray. Keep me honest there. Yeah, we're going to go look at the Hubble image, but I just kind of wanted folks to see the closest that the RASA could get to it. Notice that when we bring these mids down, the outer shell kind of becomes a little, you can see the face and then the inner hood inside of it. But we have to go to 250%. So we're way into the, what you might call the digital zoom. And going back out to maybe 130%, look how small the clown face is. Let's go look at the Hubble image. Sorry for that blinding light. So we're going to look for NGC 2392 wiki, the Eskimo Nebula. And look at the Hubble image. Is that not wild, or what? Now, the Hubble, granted, does use a different palette for its colors. This kind of almost orange, if I remember right, is a little bit of hydrogen mixed with other things. But it does show you clearly the smile of the Eskimo face, which is this double sphere. In other words, remember how planetary nebulae are made. The dying star casts out its dying breath of object, and then it collapses on itself and it refires again. So years later, it can cast out another layer of jettisoned material. So in this case, this outer shell was cast out, and I'm sure traveling very fast, and then this inner shell was cast out, and it looks like maybe there are even 2 stars here that Hubble found, and those 2 stars are playing with the gravity of these backlit inner gases. Makes it a beautiful shot, doesn't it? Just kind of amazing. So I wish we had a Hubble out there in the observatory, but unfortunately in our observatory it's just this, 11 inches. On the other hand, it's fun to see that you can at least see a little miniature version of this RASA. One of the reasons why the RASA is such a bad imager of this Eskimo Nebula is that it's under 1 degree. It's under 1 minute, 1 arc minute. But another reason is because the RASA has only, what, 640, is it? 640 degree focal length. You would need something like a 2500 focal length telescope to really zoom in on this image. So that's the first image that the Hubble took after the resurfacing mission in 1999. Stu, good to have you aboard. Glad you made it, Stu. Better late than never. That's okay. It's all supposedly being recorded. We're just doing our last image of the Eskimo Nebula here. Saving exactly a scene. But boy, this picture, when we actually look at it, it's going to be this tiny, tiny little, like a planet-sized dot, you know. So it's not going to be very, you know, it's not going to be something that you'd write home about. But anyway, that's the Eskimo Nebula. Let's finish this. This NGC 300. No, that's not 300, is it? NGC 2392. 2392 really does look like an Eskimo. We could even see it a tiny bit in the RASA live view. But the Hubble view is the best. And you've seen it live now. So when you see that famous image of the Hubble, now you'll be able to say, I saw that live. We'll run our objects one more time. And look, we have an object at 10 degrees. And the way this is set up, we're supposed to be using our local horizon model. So technically speaking, if it's eligible to be seen here, we should be able to image it. So let's try it. Let's just give this a run for its money. We're going to show it in the chart, and we're going to slew to it. Look how low this will get down on the horizon. We're going to test how accurate our horizon is. It's going right over there, that light dome. This is, again, C70. "10 degrees above the horizon." I mean, surely our trees are 10 degrees, but let's try it. Let's go look in Stellarium. No, let's don't go there first until this settles. Oh, so we went way around to the south. Look how the scope is pointing now toward the south. It's pointing over the camera's head, so to speak. So that should be a settled view. Now we should be able to start the... So there's our RASA image, and here's our photorealistic horizon. This is a favorable, actually a favorable part of the horizon for us. Supposedly, look at this. Let's take a read off this string of pearls. That has an altitude, oops, I better get you guys on the screen. This string of pearls is supposed to have an altitude of 5.5 degrees. This star is supposed to have an, by the way, did you see the RASA move? It did its plate stop. This is supposed to have an altitude of, wow, 3 degrees. Look at that spot. So this star, let's find one right here, for example. That star is currently at 6 degrees. So we have a 6-degree tree horizon here, supposedly. Now let's see if it's actually real. First image coming in. It is. So we can actually see an object that's just 10 degrees above the horizon if we go to this southern part of our sky. That's a lot of fun, isn't it? Thank you, Emerald Hills. So we're going to do that thing one more time. We're going to bring these darks way over here to this crest and start working up these mids. And we're going to just use our deep sky image annotation. Okay, so it thinks that NGC 300 is over there. Let's do a plate solve, but not resync. Plate solve only. And that will take a read off these particular stars, and it will fine-tune that deep sky image annotation a little bit more granularly. Stu says, we could have almost seen the tree nebula. Asray's admitting to Stu that he was late as well. 620, thanks, Asray. 620 for the RASA 11. The RASA 8 is 400, yeah. The orange probably is hotter, by the way, Mario. Stu, discontinued use of 3 nicknames that were perceived as offensive. Eskimo Nebula, Clownface Nebula, and Clownface Nebula were all discontinued or recommended the nebula be referred to by its NGC designation. Wow, Stu, thanks for telling us that. So we're supposed to be calling it the NGC number instead and stop saying Eskimo Nebula. Huh. So there you go. Okay, so let's go to the, now that we're resolved. Okay, right there in the middle is where this should be. I thought that our plate solving would have done a better job. It was just the image annotation that was off a little bit. So when we resolved this image, it squared up our image. So right there in the middle is where this galaxy is supposed to be. So let's take our image annotation off, and let's, this is 120 seconds, start pumping up our mids, and let's zoom in. Boy, does anybody see this galaxy yet? This is supposed to be C70. C70. Southern Pinwheel. It's in the constellation Sculptor. We better finish our title down here, huh? This is C70. NGC 300, a galaxy in Sculptor. Sculptor. Is that right? Sculptor? I'm just not seeing it yet. It's not happening yet. Let's read about it. Huh. It says that NGC 300 John Herschel took credit for it, but James Dunlop had already cataloged it 7 years earlier. He was in Australia. You Australian guys will like that. Try the auto stretch in a live histogram. Okay. You're right. What the auto stretch did is just caused us to put our black level a little bit to the right. I mean, a little bit to the left of the crest, so that we could bring in a little more of the night sky. Yeah, and the mids, let's bring the mids way up. You can just barely start to see it there, huh? That's 4 minutes of integration. It's a difficult object. It's a barless spiral. Not going to get any alcoholic beverages out there tonight. Loosely wound arms, tiny nucleus. Looks like a miniature mirror reverse version of M33, the pinwheel galaxy in Triangulum. 2 dominant S-shaped spiral arms, laced with dark lanes and starry clumps. 2 other feathery arms, forming a weaker S, complete the pinwheel pattern. 46 degrees from face on. True diameter is 22,000 light years. So that's about, what? 20% the size of the Milky Way, huh? 30 billion suns mass. Has an underlying population of old stars. In infrared, it's a lot brighter. You can just barely see it, he says. The light is spread over such a large area, the surface brightness is low. So some people might scan this part of the sky and never see it. I agree. I wonder also, let's take a look real quick at the sky cam. Oh, look what's right there in our path. That giant searchlight you see is apparently the moon, huh? Obliterating this part of the night sky. Let's go back in Stellarium and back off enough to see where yeah, there's the moon. So, forget how you do it in Stellarium. You guys might remember, how do you figure out the arc minute of extent? Where is that little setting here? To figure out arc minutes. Isn't it down here somewhere? I thought it was. Anyway, we can estimate, can't we? Because this would be 205, and that would be 235. So 30 degrees. So if that much is 30 degrees down there on the horizon, this is probably 40 degrees. And that is really whitewashing our image. And we are at just 9 degrees above the horizon. So that doesn't help matters. But let's see what we can pick out here. Try to increase the contrast with the dark sky. There's not much dark sky there. Looks like that's the best we can do. You can definitely see the S shape of this larger whirligig. It's not beautiful though. Too much close moonlight, too many atmospheres. You know, the cool thing about Deep Sky Planner, it actually tells us how many atmospheres we're looking through. It calculates that. How many air masses? 6.11. And you want your air mass to be like 1, which is imaging pretty much straight up. And then as you go down the sky, you're going at an angle through the atmosphere, so you're actually imaging through lots more air. So you gradually get down to 2 air masses, 3, 4, 5, 6 air masses, and each air mass kind of disintegrates a little bit of your sky. Amazing to see something 7 million light years away when I have trouble reading a book right in front of me. Well said, Dennis. Azray, yeah, to see it brighter. We're trying to see something 7 million light years away, Stu says. Why don't we say that? 7 million light years away and only 22 light years across, lost in 6.11 air masses at just 9 degrees above the horizon. But it was good practice to try to bring it in. I mean, you stop and think about something like a Messier marathon. This is what you have to do. You have to be so low to the horizon that it just seems impossible. You prefer to measure the sky in arc fingers. Oh, astronomers speculate that NGC 300 central black hole is a new kind of Wolf-Rayet black hole binary system with an orbital period of 30 hours. That's crazy, since it's probably a light year or two across. Fourth button at the bottom in Stellarium. Fourth button at the bottom. I must have that button turned off. I bet I do. I'll look that up and I'll get it set next time. I must have turned off that button by accident or by thinking I would remember the keystroke shortcut, and I don't. Okay, one last tune-up here. Let's try to darken the sky around it one more time, such as we can. And then let's try to bring up the mids as much as we can. Boy, combined with the horizon and the moonlight, that's the best we're going to do. Probably not worth taking a picture of that image, but we did at least identify it and find it for the sake of, posterity. So in our observation, we're going to see, we're going to say our image was whitewashed. Just click it and it should show up. Our image was whitewashed, but at least we identified it. Well, Azray, now you've got my curiosity up here. Yeah, see, the icon is gone, I think. I tuned up Stellarium, and there were several keystrokes I thought I would remember, and I haven't. I'll look that up and I'll have that figured out next time so we can figure out the arc minutes of extent away. Okay, we're at our last 2 minutes, so I tell you what we'll do to close out. We'll just stop live stacking and go to 3 seconds manually here, because let's go real quick to look at Jupiter. Jupiter. Why is it showing it as not visible? That's crazy, isn't it? Let's just do it in Stellarium. That'll be quicker. Jupiter. So there's Jupiter. And let's do Control-0 and say current object and slew there. So a little bit of an adjustment, but not much. There goes the RASA in the screen. Isn't that fun to watch that RASA kind of like the representative of the RASA. Watch it travel across the sky. That's fun, isn't it? And there's Jupiter. Let's drop back down to auto. Oh, it's real close to something. That must be the observatory wall. That's wild, isn't it? So we're seeing currently 3 of the Galilean moons, unless that's one. But look at these 3 giant moons. So let's remember what these look like. And now let's go over to Stellarium and zoom in. So that's Callisto, Europa, and Ganymede. We might be able to see Io very close to Jupiter. So let's remember that order. Callisto, Europa, and Ganymede. Callisto, Europa, and Ganymede. And then let's zoom in closer on Jupiter. Evidently Io is being lost here. It's the best I can guess. Let's make sure our time is correct. 23, yes it is, on 12-1, yeah. So it's just lost in being too close to Jupiter's surface, lost in the glare. But let's do, check this out to make sure this is not a moon. Nope, that's a variable star. I don't think we're going to see these. Amalthea and Thebe are going to be lost in the glare as well, I think. But let's try. Oh, we're picking up this. That was called Amalthea. Amalthea. How about that? So we're seeing one of the non-Galilean moons barely right there. I don't know if you're picking that up on YouTube, but it's just the tiniest. Oh, and there's the other one. So Amalthea and, oh, I'm sorry, Thebe and Amalthea. So that's Thebe and that's Amalthea. That's amazing, isn't it, that we can see those. At least I can see them. I don't know if you can see them on the YouTube, but there is Thebe and there is Amalthea. And if we live stack that, those would come into more visibility. I like the way they're a little bit farther from the moon, so we can, farther from Jupiter, so we can see them. Let's end on that note. I should have changed our title so people don't think that we're Jupiter and its moons. Thank you for being a part of this, the 100th night of observing for us, and the 150th recording. I hope that if you've been with us throughout the whole journey, boy, I can sure remember how recklessly horrible it was those first few nights trying to learn how to use an equatorial mount from scratch. It was crazy. Operating in that cold truck with the heater on, you know, eventually it would warm up some with the window open a little bit and that USB cable 25 feet out there on the road and the tripod, setting it up for 90 minutes in the cold, 29-degree cold. And then when we're done, that was the worst part, having to tear it back down. Because, man, there's no adventure in tearing it down. You're just freezing to death. Your fingers are freezing. My fingers would crack. And now, what a difference it makes. If you like content like this, if you wouldn't mind clicking that thumbs up, doesn't cost you anything, gets it in the search window of the next person a little better. Invite you to subscribe. Stop by the website if you want, emeraldhillskies.com. You can sign up for an email alert there. When you subscribe to the YouTube channel, if you're subscribed to YouTube, I mean, if you have a YouTube sign-on, it'll alert you here. We try to live stream once a week, and this is our 150th recording, 100th observing night, and we've really only been out at this a year and a half, so that's pretty much the way it's worked out. Thanks for being a part of this. We appreciate you. We appreciate you observing with us. It feels like we're a team. Don't forget to watch the U.S. men's national team day after tomorrow in their 10 a.m. Eastern Time game. Perhaps against the Netherlands. If you're from the Netherlands, may you guys win. But boy, if you're from anywhere else, go USA. I'm going to look here and see what else anybody else has said. Slew Baby Slew, Stu says, where did the term slew come from? Stu thinks it's an old sailing term. Dennis says sounds right. It appeared in American colloquialism in the 19th century. Origins unclear. Perhaps taken from the Irish slua. Thanks, Stu. Have a great rest evening. Thank you, Mike, for the congrats on the first 100 observing nights. Thank you again for being with us, Stu. Thank you, Azray. Kim, I can't believe you stayed with us the whole time. You are much more experienced. You should be doing this instead of me. But thanks for staying with us. And God bless you all. Thanks to God for making all these amazing sights for us to see. Have a great evening. Take care. God bless. And good night from Emerald Hill.